So I would like to call Mr. Manish Bhasme, CFD Consultants. Yeah. Over to you, sir.
So without a lot of time, I will try to make this conversation very easy, and I will try to highlight a question that triggers me when I was in BTech and MTech. So first question was when I was in BTech, that how the CFD industry make the money, right? We seen a lot of slide, a lot of research work. So let's go to the slides like how this industry actually works. So before that, I just would like to express myself. I'm Manish. I hold BTech in chemical, and then I did masters in chemical plant design. And during masters, I seen my lot of friends who are doing titration, and that's the reason I don't want to spend a lot of time in titration or chemical engineering. I took a very easy subject. So I just want to be sit in the AC lab, where having a HVAC, a good airflow, and just want to sit in front of computers. So while doing this CFD, I gone through a lot of equations. So I did a CFD which can pass my paper. Okay, so that's what my background for the CFD. Okay, so let's go to the first part of CFD. It's CFD and its industrial application. So how this CFD industry makes the money? The first is compliance project. So there are a lot of rules and regulations for every industry. Let's say if you are into pharma industry, where this pharmaceutical medicine made or vaccines, while they are filling, they have certain norms. If you don't follow this, the government or any advisory board doesn't give them an agreement. So before install any those system, they want to prove that whatever HVAC system they are supplying, it's good, it's going to be work. So it is a compliances. So in that reason, the CFD comes into picture. You need to satisfy those norms. So CFD has a lot of business in this industry where compliance comes. So I will show some examples. Car park. I don't know whether in India it is very compulsory, but if you are going to the Dubai, desert zone, Saudi Arabia, they having the atmospheric temperature around 45 degrees Celsius, and if you drive this car into such a desert and you are parking into your car park, it's possibility that it will catch a fire. Okay. Then government comes into the picture and asks them, why shouldn't you provide us a HVAC system that show that if you burn the car, and let us show the HVAC system you have proposed. Let's say I'm burning one car here, and I'm showing the government that, okay, we have this HVAC system, if you see the pink color, okay, and this is 4 kilowatt of car being burned, okay. So then we are performing simulation and taking out all these burned carbon monoxide out. So how it get passed? The government provided norms that within this second, the CO concentration at particular level should be this, okay. The values vary country to country. The Dubai has different norm, Australia has a different norm, Singapore has a different norm. It's vary to the geographical location. So in such a case, it's very important, and to be honest, if you go to perform this simulation in actual practice, it will going to be cost one car cost, which is in million, right? So CFD save a lot of cost, give them a compliance CFD report so that their project can get approved and get finalized. Then another into the storage things. Let's say the Amazon, Flipkart, if you are working with them, you are having the storage, right? So also they have, if we are storing our product there, so they are asking what is the ACH there, because ACH is the air change per hourly. If you want to store a good product, you need to be ventilation, the natural ventilation. Since you are not putting any forced ventilation with the duct or anything, the fans, it's all depend on how the surrounding is, right? So we perform CFD simulation on the basis of geographical location and what is the data available, the average velocity throughout the year. And they have a lot of openings. Let's say this warehouse having the shutters, the windows and door all. And then we throw the air and then we calculate the ACH. Okay. So that's how the compliance work. Another one is the data center, very common. So before installing any data center, let's say I perform this for the Airtel. What they are doing, they are proposing some, the data center, their manufacturer, and they want to make sure that what is the HVAC system they have applied. It's taking the good amount of cold air and cooling their server. If there are, heat spot or all the, they can, very important to show the evidence that this is how their HVAC system is. Okay. So this is one compliance thing. Second, is the, cross verification. So this is one of my customer, and this equipment is cost around maybe 2 crore or 3 crore. So before manufacture this one, he want to perform simulation and cross check if this equipment being manufactured, how it will perform, whether it will deliver the same amount of temperature that he designed for or not. So before manufacturing, we can perform the simulation and letting them know, Baba, oh sorry, this can be a temperature and it is not being achieved, so he can take the action by that time. So this is how he can with a lot of cost before he manufacturing. Same thing is here for the plate heat exchanger, the same thing. For the double pipe heat exchanger as well. The steam tank. Saudi Arabia, where we have the petroleum industry, and once they took out the lot of crude oil from the earth, let's say, they process into steam tank where the oil and the petroleum product get separated, and it's depend upon how this petroleum product and water interact, whether it is providing sufficient residence time for the petroleum product to move upward or it is getting out. So you can see we have performed a lot of simulation. So our existing customer having the petroleum product of the particle size, let's say 120 micron. The initial efficiency was 55 micron, and with our consultation, with a small modification, we have achieved up to, I think, how much? 85. So it's, and you can multiply this efficiency to the number of working hour, maybe it can be run for 2 years continuously. So you can calculate how much cost we are going to save for our customers. And that's why they are willing to pay anything if you are doing small changes for the petroleum industry. Another thing is electronic cooling system. This is not a common system. Let's say it is not for Dell rack server R30 or common product. It is for the military product, because military configuration is way higher than what we normally use. They maybe use 5 GPUs, 6 GPU, and the 1 GPU almost cost 6 lakhs. And it is not about the cost, but also while doing the military operation, they doesn't want to lose any data. So they want to make sure how their system is cooling efficiently or not. So what we can do in the simulation, you can see this fan placement is not good. It's being circulating. It's taking the air, throwing here, and getting circulating back. So it is not getting cooling efficiently. So that's the reason the temperature of certain GPUs getting higher and low. So you can place the one plate here, so that can be blocks recirculation. But still, it is electronic thing. If you make a small changes, the entire electronic engineer will be, fight with you, because again they go back to the motherboard, the placement, all those things. So it is way complex in terms of electronics. But in terms of big HVAC industry, you can take a duct out or fit anywhere. That's not a problem. So same for NVIDIA we have performed, but it is not for the standard NVIDIA. My customer use 4 NVIDIA graphics card here, and he were interested what is the temperature, and you can see the temperature is 100 degrees Celsius, and that decreases the efficiency around from 90% to the 80 and 75%. So that's not a good thing. This is another project. Okay. You can see this chiller yard. So what exactly chiller yard is, I will let you explain. So we are having this AC system installed in our office. How it is being cooled? Because it is taking the heat and discard into the environment, right? So it is taking the heat and spending to the environment, right? Exchanging. So this is chiller yard. We have somewhere it is placed outside the window. Maybe that's why you are seeing a lot of AC system hanging on outside your building. What happens if I am cooling air using from the atmosphere? It is being circulating back to the same thing. So in that way your delta T got decreased. Once your delta T got decreased, your heat exchanging rate is going to be decreased. But at the same time, you are spending a lot of electricity for this compressor, right? No matter what you are spending, but it is not working efficiently. So you can calculate it is not about the one chiller yard, but entire Middle East is depend on HVAC system. A small modification if you make a change, that will impact highly on their cost. So that's what importance CFD bring into those areas. Okay. Then third application is problem solving. So this is one from the military project. Let's say the military people are working there, sitting, and they're having the rack server system. So you can see how air is flowing in, coming out. So people are not feeling comfortable, and the cold air is not getting distributed into rack server system. So in a case it can fail, or people not feeling comfortable. So such an issue can be solved, and I think the previously in the locomotive, what he is told, the same thing we can do here. This is into the process industry, problem solving. So this is one of the project from, let's say, my MSME's customer, and you can see how his reactor looks before CFD and after CFD. So we can predict how the particle flow, because this spray dryer thing, you cannot see what's exactly happening into the, inside the metal walls. And CFD letting you know how's their moisture content, how the air is going to be flow. All those thing information we can change. The cyclone, all those things. This is what problem exactly occur in such a system. While delivering manufacture such a cyclone, they commit a lot of efficiencies. Like we will give 100%, 95%, all those things. But once they are installed, they are getting minimal, separation efficiency. This is fine if you are having the cement industry or your product is somewhere raw. But if it is pharmaceutical industry, a gram of, product cost a lot. So in that regard, they want to increase their separation efficiency. You can see how my customer having the initial separation efficiency and how we achieve their, higher separation efficiency with our CFD simulation and consultation. Similarly, this is one of radiator from my client. They manufacture and they made 20 pieces, and none of them is working because of the pressure drop. They may be provided narrow diameter, which is not good. Their engine is not capable of forcing such a pressure, and in that thing, so CFD helps. We help them out to change their dimensions, all those things, by making a minimal modification here. And in that way, we save a lot of cost for them. So here's the application for, the problem solving approach can be done using CFD. Same for paddle dryer. This is very interesting case. Let me tell you this very interesting case. I was visiting one of customers, and accidentally I found this piece of equipment, and he's selling this equipment from 1995. And I observed this equipment around 2018. Say he's selling this equipment from past 20 years. And I told them there's a major bypass in your system. So what is the process time you are taking? It is batch equipment. So he's taking 6 hours to get that product out with a proper heat exchange. I told, what if I can make the modification and let you know the same system and your process time can be break down to 3 hours or 2 hours. And this is where he, expresses gratitude toward the CFD, because what exactly MSME people do, they take the product, take it to the home, do the operation, take out all part, and do the copy paste. So what mistake have done in the previously can be get repeated. So in that regard, CFD helps, and you can see what is the residence time, like time taking for me to get steam into the 3 paddle, it was 50 seconds, and with simulation I took it to the 3 seconds. So now the batch time for the 6 hour can be broken down into the 1 and 5 hour. So you can imagine how much amount of benefit he got. Means the same factory, he's paying for the working hour for the 1 day, and he's getting, let's say, 1 ton of the product for 1 day. Now he's getting 3 or 6 ton. So you can calculate how much profit he's getting. The fourth part of industrial application, it is innovative type of research product. So we having a lot of customer from the pharma background, because their viscosity change, density change, all those change, their residence time change. So they cannot perform this, RTD analysis because it's very expensive. You need a lot of separate, and there are a lot of parameters they want to study, and it is not feasible with experiment. It's feasible, but then you need to, you have to be very patient and spend a lot of time. So with CFD simulation, we can give you RTD data. So we can apply 1 parameter model, 2 parameter model to calculate what is dead zone in your CFD tank, what is the bypass in your tank, right? So all these things you can calculate using CFD. Another in research area, because we are highlighting the research area, I have a lot of customer. They just take the equipment and come to my table. I want this to be done. This is my competitors. Do the CFD and do a better than this. So there's a lot of research. They come and give me for blower we can generate pump curve or pressure, that all those things. For this pump as well, you can see centrifugal pump. It is outward pump, and it has a lot of drawback. This is probably from the Netherlands, because Netherlands is the country, it's below the sea level. So what happened? Because of this country is below the sea level, it's occupied with a lot of sea, and government is very concerned if something they want to touch to the water. If they want to change something to the water, the governments come into the picture and they say, first perform CFD simulation and let us know what will happen. Otherwise, it was a flood in 19, I don't know which year, the entire country, half of the country people get flooded. So more into the specific to the Netherlands, they are very concerned about this. They want to perform CFD simulation for whichever area water they have, pump sum, water treatment, nowhere it is. So they perform a lot of things. So windmills nowadays, this quite common project. Again, this research project, my client having this huge reactor, and I wasn't confident about his, thermal calculation, because you can see this is a thin, what is this, fins, and it is 0.3 mm, and you cannot measure the CFD. So what I have proposed is to make a simple small reactor, let perform CFD calculation experiment, and try to in between way, so we can model in very simplest way. So we have done this. Multi-phase product again is petroleum industry. So petroleum industry, a lot of time not having only the liquid, but sometimes gas is also coming out. So when gas and liquid comes into the picture, there is a bubble flow and it oscillates a lot. So one of my client having installed this one, and their worker is not want to work on the floor because floor is vibrating a lot because of the flow, and they don't know which area is problematic, because entire floor is vibrating. The source of vibration itself are creating vibration, and then it is getting transport. So they don't know where actual location is. So through calculation we predicted the actual location, and they taken care and they solve the issue. Okay, now the first part is complete, that what is CFD and how it is being implemented and how people make the money out of it and how we can generate jobs for the people. So to say, that's what I think we are focusing, right? So what I would like to highlight is in the Maharashtra, if you look at the only Maharashtra, because I work in the ground level, so I know, let's say it's all like 1200 MSME, it is not a small number. And such an industry having, they having their own design, okay, but it is not well engineered, that I can say from my understanding and what kind of customer I have. So this industry, this 1200 industry has a lot of huge potential for the CFD engineer to come up with their knowledge, to bring down or resize their equipment so that they can save a lot of cost, and also the community can get benefit in terms of jobs. So that's what I am focusing. My contribution for this process is to communicate with this MSME with CFD worlds, right? So what exactly drawback this industry has? It has, the first point I will go after. The first thing is they don't have the enough finance, right? So they don't have enough money to get a CFD engineer as well. Then after, the highly paid CFD licenses. So here we can have the breakout. We can use open source software, so break down their cost. In that way, we can introduce FOSSEE there, okay? The third thing is lack of awareness. Mostly people don't know what is CFD. They are doing into the work into the industry engineer. Even the engineer don't know working there what is CFD. So here we need to spend a lot of time to making some arrangement or something that let them aware, like this is CFD can do. Yes. Third drawback in this industry, MSME is like that, because his father running his industry, let's say for the pump, his father having a good knowledge about the pump, he's going to be great for the good business for the 10 years, and after the 10 years we are seeing this industry going fall, because his son takes care the industry. He's from the commerce background, he don't know what is a pump, right? So such a people cannot encourage the technical things. So I think we cannot work here. That's a lot of headache, but I think this area we can work. Yes, so that's what my point of view, and I would like to contribute in that way. If we can reach out to the maximum MSMEs, where we can break down the cost with the help of FOSSEE. So in that way, I think we can help the CFD community who are looking forward for the jobs in the domain. Thank you.
Thank you. Thank you so much.